Assalamu alaikum. In this video, inshallah, we will see the steps to find the torsional yield strength SSY. In this question, he said the helical steel compression spring. So we know it is the material is steel, okay, and it is a compression spring. So we apply compression force on the spring. Shown in the figure on the left is made with a set removal. The meaning of set removal, it means it is the set removal this question after the set removed. So the set removed is already happened, okay, and the residual stress is already inside the compression spring. So we have after set removed. We will use this information because it is here in this table 10.6. In order to select the maximum percent of tensile strength, we need to know if it is before set removed or after set removed. Okay, with 0.3 inch oil quenched and tempered steel wire. 0.3 inch steel wire means D small, because it is for wire, D small, diameter of the wire. It is equal to 0.3 inch and it is oil quenched tempered. So this one is the material, and we need the material also because we will use it in table 10.6 in order to find the value of the maximum percent of the tensile strength based also on the material and the set removal, if it is after or before. And also we need it here in order to find the ultimate tensile strength. So we will use this one, oil quenched and tempered. This is the how we represent this sentence, quenched and tempered steel wire. Okay, and fixed between flat parallel surfaces. Okay, fixed between flat parallel surfaces. This sentence will help you in order to find the end condition constant alpha. Okay, here if you see the section for checking for buckling in the equation sheet, the value for end condition constant alpha depends on the supports. The spring supported between flat parallel surfaces, fixed ends. If you have fixed end, then alpha is equal to 0.5. Okay, so in this question also he gives me the outside diameter is 2 inch. So the outer diameter OD is equal to 2 inch, and the length L naught is 9 inch. He didn't mention anything about it is solid length, so it is not LS and already I don't have YS in order to calculate LS. Okay, and I don't have anything that represents KS LS in the question, so it is L naught. L naught is equal to 9 inch. Okay, we have 3 questions in this video. Answer the following number of the total coils. So if you want to calculate the number of the coils, first one is you will consider it equal to 0. Okay, the ground, the fixed. Okay, then you will go to the other coil. So this one is equal to 1. Here is 2. This one is 3, 4, 5, 6, and 7. This one is 8, 9. This one is 10, and the last one is 11. So the answer is 11 for the number of total coil. We will make a video about number of coils, how to calculate the number of total coils in other video, inshallah. But here we will focus on calculating the torsional yield strength. In the question, he said shear stress should be equal to of the ultimate tensile strength. So it is a percentage or a value of the ultimate tensile strength SUT. And he said shear stress. I don't like this word shear stress because usually we say it is torsional yield strength SSY. So he means the torsional yield strength. What is the percentage of the torsional yield strength from the ultimate strength? So we need to calculate the maximum percent of tensile strength. this one. Okay, that is why he gave me that it is after set remove. He said with set removal, and also the material is oil quenched and tempered, so I need this one tempered. Okay, then I know that the answer will be 65 or 75, or I will take the average. Usually we take the average, but here in the multiple choice I don't have 0.75, I don't have 0.7, so the answer is 0.65. This one is the correct answer. Okay, what if he asked you in the question calculate the torsional yield strength based on the previous question? So we will use 0.65. Why? Yani if you see how we can calculate the maximum percent, how we can calculate the torsional yield strength, we will multiply the maximum percent of tensile strength from table 10.6, this one 65. Okay, or we will multiply it by the percent, so it is 0.65. In this table you take the percentage, yani if it is 65 means 65 over 100. Okay, this means 0.65 times the SUT. SUT, in order to calculate SUT you need table 10.4 in the material oil quenched and tempered, so we'll use this row. Okay, with the value of M, we have the units in inch and kilopound per square inch. We don't we in the question he didn't use the SI units, so we'll use these two columns. Okay, the value of M is 0.187 and the value for A is 147 kpsi inch power 0.187 M. Okay. And then we will use this equation to find SUT, and we already calculated the maximum percent of tensile strength 65. Okay, so 65 times SUT will give you SSY. That is why what he needs in the question. Okay, so first, in order to find anything in the mechanical springs chapter, you need to find the mean coil diameter. Okay, either you use this equation or use this equation. Usually we will be given the outer diameter, and in this question we have the outer diameter and the inner the wire diameter be small, so we calculate the mean coil diameter. So it is D equal to outer diameter minus inner diameter 2 minus 0.3, and it is equal to 1.7H. Okay, and from the table 10.4 we can get the M and the exponent and A. And then we can use this equation to calculate SUT. After we calculate it, SUT, we can multiply SUT 184.12 kilopound per square inch by 0.65. Then we can find SSY, the torsional yield strength.